Hi everyone. So in the last video in this series of Kubernetes, we have learned about replication controller, replica set, and deployments. So now we are going to learn about the services in Kubernetes. What is services in Kubernetes? So so it is like an abstraction that defines the logical sets of pods, and by policy which do we have to access. So this is about the definition basically, but let's go and understand basically what is pod. So what is services? Okay, so as we know that pods are ephemeral in nature, right? So ephemeral means in nature means it can be created and destroyed, right? Destroyed. So and that too it is a dynamically, right? So pods can be created and destroyed dynamically, and and if somebody is there who wanted to access the pod, right? So we don't and if you remember last time we have already seen that when we create a pod, right, it generates a unique ID IP address for it. Okay, unique IP address for each pod, right? And when it is newly created, what happens is new IP address get created for the pod, right? Now you assume that there is a client who is trying to access a pod on some specific IP address. Okay, let's say it IP1, and after some time the pod got recreated. Okay, and the client is trying to access to that same IP1 IP1 IP address, but pod will what it will do is it will have another IP address IP2. So due to which here the connection was able to meet, or we were able to connect it, or we were able to send the request. Here it was successful, but here what will happen is the request will fail because the IP address got changed, right? So every time client was trying to request the pod, it can change the IP address dynamically, and as we have learned in the previous sessions, deploy what will happen, deployments and all, it will recreate another pod immediately, right, based on the replicas. So due to that, these pods will get a different IP address. So client will keep on failing. Okay, the request will not go. To overcome this challenge, what we have what new service Kubernetes gave us, they have given a service. Okay, so services, services in Kubernetes. Okay, that's the topic came in picture. Okay, so services ensure that the network can be reliably reached to the correct pod, even if the pod dies and recreates. Right? I hope you understand what I'm trying to say. So even if the pod is dying and recreates, services ensures them to services ensures that traffic is reliably reaching to the correct pod every time, right? And how many types of pod services are there? Now since we are touching the services topic, so first one is we are also going to learn is cluster IP. Major, let me write what is the main important. Second one is node port. Third one is load balancer. Okay, then there is fourth one is external name, and the fifth one is headless service. Okay, so these are the main services in Kubernetes, but in general we study about these first three. Okay, so in this today's topic we will discuss about all four five, but we will go on the architectural diagram and understand about these. Okay, so what is cluster IP before I go into the architecture diagram? So what it does is it exposes the service internally inside the cluster. Okay, so every cluster will have one unique cluster IP service, and that will expose the all the services. But basically, it will bring all the connections within inside the pods. It will help to connect between each and every pod. Okay, for the communication inside the cluster only. Please remember, only within the cluster only. Right? What is NodePort? So it exposes the service of a static port to the node IP address. Okay, so that is the benefit of having node port here. So it allows the external traffic to reach to the cluster, right? So if here we have understood, right? Here we cannot, okay, here we cannot create any external traffic. The pods has to connect only internally. But in this case, the pods can connect externally as well from the external traffic. Okay. So what is load balancer here? So load balancer provides the external load. So basically it's kind of same like we have in Azure or AWS, right? So it is going to perform the same role here. It is going to balance the load and it is going to distribute the load, right? So production, mainly production and all workloads to handle those places we will use load balancer. What is external name? Okay. So what it does is it maps the external names, maps the service to the external DNS name instead of any IP address. Okay. So here we were connecting IP. Okay, IP. So external name is it will map it to some certain DNS name instead of an IP or a selector. Okay. What is headless service? Okay, it does not it does not connects with the cluster IP and it directly gets the access to the pod. Okay, so it is going to directly connect to the pod. So and I would say this is a special service, I can say. Generally we do not expose these kind of things, but if you wanted to expose your pod directly, then you can definitely use this approach, right? uh, Now let's go and understand about the next thing. Okay, so before I go and touch the architecture diagram, let me explain you with the example also, right? So what happens is, let's say, let's say in a cluster IP, right? So you are living in some, or you are staying in some apartment where you got some extension, or you got some, let's say, let's take a simple example. You are in office. Okay, you have an office of 7 floors, and from one floor to another floor there is a extension. You have 4-digit extension number is given, right? And you wanted to connect, so you dial those four numbers like 1234 or 0000, and you will be able to connect it to the reception. You will be able to connect to any floor, any person, right? If you have an extension number, right? So internally on your office you will be able to connect with those 4-digit numbers to the telephone. But if somebody is from outside the network, or somebody who is not from the building trying to access or call those 4-digit number, he will not be able to connect to those people, right? He will not be able to connect to the reception or any places, right? So basically what is happening, only internal connections are happening. That is called cluster IP. Okay, now let's understand what is node port with an example. We have already understand, right? So node port, what happens is, you take an example of reception desk with a direct line, right? So you have a public number. From your public phone number, you are calling to the reception. Okay, and there is a receptionist sitting there who will be able to direct you to the correct person, and he will be able to tell you, okay, go and talk to, okay, you wanted to talk to this person, let me connect you to that person. Okay, like that node port will work, right? What is load balancer? Okay, you take an example here of, uh, you're calling at any call center or a service center. Okay, and you called any call center, and you tell like, okay, when you call it, you dial that number, and that request will automatically go to the person whoever is free, right? It will not, somebody will not pick you and route you to the another person. Rather, when you call it, it will directly goes the request, or your phone directly dials to the person whoever is free in the list. Okay, so that is called load balancing situation. Okay, so that is something like load balancer. Now let's say about the external name. So basically in external name, right? So imagine like somebody moves to another country, but you still sends a letter to their old address, right? So the postal service, what postal service will do, it will forward the mails to the new location without you know, right? Without you knowing, So it is going to send all the address and mails, right? So that's how external name work. And in case of headless service, okay, in case of headless service, what happens is, so you suppose you directly, you are sitting in some company, okay, let's say you are on 7th floor, any floor you are sitting, but person from the outside world, right, he will be able to directly call to that person directly, not even trying to reach out to reception or anybody, is directly calling to the person. That is called headless service. Okay, you can call them directly skipping the receptionist. Okay, so headless service is like giving out direct contact number instead of main line, right? That is called headless service. Okay, so I hope these examples I gave is easy to understand and correlate. Now let me explain you about the first service through the architecture diagram as well. So let's say the cluster IP, right? We discussed about the cluster IP. So what we discussed in the cluster IP, that only it will be able to expose the service internally within the cluster. So let's say this is a cluster, right? So you are able to expose the request only inside. So outside, if any request will come, right? So let's say if this request is trying to come here, okay. So so if any request will try to come here, so it will get rejected here itself. Okay. So the request will get failed here itself. Okay. So the request will get failed here. It will not be able to go inside this. Okay, even if you will try to reach out to the client, you will not be able to reach out. Or cluster IP, you will not be able to reach out to the cluster IP. Basically, all the requests will get failed. But you suppose you are trying to access from inside the cluster, and client wanted to talk to this pod or this pod, any pod inside the node. The client will first direct or request the cluster IP address. Based on the cluster IP address, it is going to route it to the correct pod. Okay, so that's what this is called as cluster IP service. Okay, so it is used mainly to connect internally within the cluster. So let's say there is another DB pod or database pod, you will be able to, and client wanted to connect to this, so client will first send a request to cluster IP, and then it will send a request to cluster. So DB basically. Okay, this is another pod. Okay, so like that it will be able to send the request. Now second thing is what we have learned about. Second thing, that is NodePort. In case of NodePort, what happens is, okay, so if anybody wanted to get the access to these pods, right, what will happen is, let's say if there are uh, if there is a client is sending a request, so instead of service IP, there is another service came in picture, that is called NodePort. So what NodePort does is, first it takes the request, okay, and then it's route the request to the cluster IP. Then cluster IP send the request to the different pods. Okay, so that is called NodePort. So what is NodePort here? As I told, it exposes your application on the static port. Okay, and on every node IP address. Okay, so let's say I'll show you the another example. If there are two nodes, so it will take the IP address of both the nodes, and it will start routing it to it. Let me show you in soon. Okay, but before we go ahead, the important thing to note here is, okay, for the node port, when we create a node port, it it has a port range of 30,000 to 32,767. Okay, that's the, and these are all called high range port. Okay, and now behind the scene, what it happening is, when you create a node port send a request to the cluster IP as we see in the picture. Cluster IP send the request to kube proxy. Okay. And kube proxy will send the request to the backend ports. Okay. So that's how the flow goes in NodePort. Okay. So I hope you are able to get this example also. We will we will check everything in a hands-on very soon, but let's understand the architecture first. Okay, now let's understand about the load balancer. So this picture will give you more clarity actually. Okay, about the node port as well as load balancer. So let's say you have a client, right? And client is sending a request. Okay, he does not know okay which node is having enough number of machines available for your service to or application to run. Okay, so he will just send a request to the load balancer. Okay, and load balancer, what it will do is it will behind the scene it will create a node port, and node port is going to create a cluster IP. In the previous example also, right, when we create a node port behind the scene it is automatically going to create a cluster IP service. Okay, so that you do not have to create. Okay, when you are creating a node port, automatically cluster IP service will get created, right? Same way, when you create a load balancer, automatically node port and cluster IP service will get created. Okay, now when you are sending a request from your load balancer to node port, what actually happens is node port have all the information of the node IP address. So you see this diagram. So if you see this line here, okay, this is node here. This is one node, this is another node. So in this you see there is one line coming here, and it is sending node is sending its IP address. Node port will get the node's IP from the nodes. Okay, node ports will get the node IP from its node. So node port will always have the information what is the node IP address. Okay, so this node port will have the IP address for node 1. Similarly, there is another node, right? This node IP address is also available with this node port. Okay, so what it is saying here is Kubernetes allocate one node port number per service. Okay, so per cluster or per service there will be only one node port. Okay, but the port is always open on every node IP. How it is open on every node IP? Because node port collects that information, right? So node port is collecting that information of node IP address from here, and it is storing here. Same way it is storing the node IP address here, and it is storing here. Okay, so the port is always open to the node IP address. So node port is always open to the node IP address. So you can send the traffic to any node IP using node port. Okay, so what you have to write is you have to give a node port IP address. Let's say you are giving any 172.168.xyz, any number. I'm just giving a random number, and then you have to give a node port this port number, right? So 172.168.x.x, and then you have to give 31,081. Okay, so this request what will do is it will directly take you to this port. It will not take you to this port, this node, right? Because you are trying to hit on this particular node, whatever the IP address is there. So IP address and then node port. What is the node port? It is 31,081. As we have already seen, right? The node port will always have a high range ports. That means it will have the range from 30,000 to 32,760 range, 67. Okay. So I hope this is clear how node port is getting all the IPs. It is collecting all the information from the nodes. And then what we'll do is node port will send the request to cluster IP address, right? That, hey, I wanted to connect it. And then cluster IP address will connect to again kube proxy. That is, we have seen in the architecture video, right? What is kube proxy? That has the routing information, which node is healthy and all. So that it will take. And cluster IP will help you to connect to any of the pods here, and your application will serve the purpose. right? So what is this? You see, this is a kubeproxy. So kubeproxy opens 31,081 port on the node's IP and ties it to the service cluster IP. That's the same example, whatever we have discussed, right? So load balancer request will come. It will send it to NodePort. NodePort will have all the information or node IP addresses because it keep on communicating with all the nodes present in the cluster. So if there are two nodes, this is one node and this is another second node, it will keep on connecting and it will collect all the information of uh, node IP address and it will store it, right? So if the request is going to any of the node, it will automatically send it to cluster IP and it will communicate to kubeproxy, and kubeproxy will be able to connect you to any of the node IP or the pods inside the nodes. All right. So I hope this I'm able to explain you very thoroughly. So this architecture diagram is very important. Okay. Uh, so please kindly go through this video again, and the next video we will upload and we will learn about how to work with these clusters and what is cluster IP. In live we will see, we will execute in YAML command, we will execute declarative imperative both way. Okay, cluster IP we will learn, then we will learn about a node port, and then we will learn about the load balancer. Okay, so all these videos, I mean all these topics we are going to discuss about in the next upcoming videos. Thank you for attending my sessions, guys, and have a great day. Thank you. Hello everyone, welcome to the session again. So in the last video we have seen about cluster IP, node port, and then we have also learned about the load balancer, right? So all these three topics you remember. So all these three topics we have discussed. So kindly go and learn about the architecture and some use cases also I have explained in the previous video. In this video, we are going to see how cluster IP is going to work in action, right? Using command prompt as well as Visual Studio YAML file, that is imperative as well as declarative way, right? So what we have discussed last time, we have discussed, right? So if there is a cluster and you have declared cluster IP service, it means any request from your outside world, right? Any request which is coming from your outside world, you will not be able to access it. Okay, so let's say if your request is coming from outside the world, that is from open place, then you will not be able to reach any of the pods. To achieve this, what we need to do is we need to first create a pod. Okay, you can say it as a landing pod or a client where when you go inside the cluster first, then you need to request on the cluster IP service of the node, right? I repeat, you need to request on the cluster IP service of the node, and that then the cluster IP service what will do, it will route to the different pods using kubeproxy. Hope this is clear to all of you what I tried to say. If you are trying to request from outside of the cluster, in case of cluster IP service, you will not be able to reach on the request on any of the pods, right? So to do that, what you have to do, you first need to log into the client. Okay, from the client you need to request on the cluster IP service of the node, and then that cluster IP service request will take you to different pods using the help of kubeproxy. Okay, so let's see this all in action. Okay, uh, so this is my command prompt. Let's ensure everything is clear. So kubectl get all. Okay, so I don't have anything. I just have a default Kubernetes service. So what I will do is I will first show you the file, right? Okay, so this is my file. So if you see, there is one deployment. I'm doing a deployment where I'm doing 4 pods deployment, right? 4 replicas I'm deploying. So if you remember in this picture, you can see 6 pods are there, right? So not, yeah, here 6 pods are there. I think I spelled out like here 4 pods, but it is 6. Okay, so what I'm trying to do is I am using the deployments. I am deploying 6 pods, which is similar to my diagram. So I deployed 6 pods using deployment file. Okay, so now what is deployment and all? I have already covered in the previous video where I have in detail discussed about the replication controller, replica set, and then deployment. You must go and understand that concept first. Okay, so what I'm doing here, 6 replica set I have deployed. Now the late new thing is here is I'm doing a service deployment, right? So what is service here? You see, service is of type cluster IP. Okay, and API version is V1. I gave the name of that service as backend service, right? And I gave a tag or label or selector, you can say, as a backend. And these are the 2 ports. So this is port 80 and target port is 80 as well, which is based on my which one. So target port is the container port. Okay, whatever container port is there, that is my target port. Okay, and I'm opening the this packet service as port 80. Right, so this is all about this YAML file. Now let me go ahead and deploy this so that we will quickly learn about it. So kubectl apply -f. Okay, then I will write my file name, which is in my current directory only, ClusterIP _1. Okay, so I pressed enter. So soon you will see, okay, this got implemented, this got deployed. Now let's see kubectl get all. If I press enter, so you will see 6 pods are in either in creating or in the running state, right? So let it load. Meanwhile, we can see, so 6 pod and cluster IP service we have implemented, right? So now you see, this is my 6 pods which is in creating state, and this is my cluster IP. Okay, so now if I try to curl on the cluster IP, right, whether I will be able to do it, let's see, curl and IP address of my backend service, that is cluster IP. So you will see nothing is happening, right? It will time out, or it will just throw an error. What I will do is, now I will show is nothing happened, right? No output came. Now same command we will execute after some while. Okay, let me show it to you, but I will just make a note of it somewhere. Okay, so I will just create a note of it. So I'll just control V here. Okay, now as per the architecture diagram, we discussed that we cannot directly reach out to these pods, right? You can take any of the IP address of the pod as well if you want. So kubectl get all. Okay, IP address is not, so kubectl get pods -o wide. So you got the IP address of pods, and now you try to do the curl url pod. Okay, so nothing will happen. Okay, both on cluster IP as well as pod, you are not able to reach, right? So I'll just stop it now. Now let's go to the diagram again. So we are not directly able to reach out to these pods. We are not able to reach out to the cluster IP as well. So what we will do is, from outside, that is my local system, we will create one pod first, that, and we will name it as client. Okay, now let's name it as client. So I will create a pod kubectl run client. Okay, and let's give image as nginx. Okay, so I gave, and the pod got created. So very soon it should get created. Okay, kubectl get all. Here you will be able to see a new pod, that is my client. Okay, so this is currently in creating state. Okay, now what we will do is, we will log into this particular pod. Okay, we will try to log in, or we will try to go inside this pod using kubectl exec command, right? Kubectl exec, then hyphen it interactive, then client is client, and then I'll mention as hyphen, since it is command prompt, right? So bin sh. Okay, so what it is telling is kubectl command, this got deprecated. What I did, kubectl exec hyphen it client, and then hyphen, I think I should write here double hyphen. Okay, so now I am able to go inside the pod. Now we are currently inside the pod, right? Now what we will do is from this pod we will try to curl now. Okay, now what we will do is we will try to, let's do it on the cluster level first. Okay, so I will copy it. If you see, this is the cluster IP, right? So I will send a request to the cluster IP. What I'm going to do is now I'm inside this client. Now I am with this dotted line you can read. I am sending a request to this cluster IP, and cluster IP in the end, in the backend, under the hood, it will, what it will do is it will send the request to any of the pods here. Okay, so now let's see it. Okay, so if you go ahead and execute here, so control V, okay, and I just press enter, so you can see, right, welcome to Nginx, and I'm able to log into the pod, right? What else we can do here? Let's try to directly point to the pod. Are we able to do it? Control V, yes. Okay, so within a I mean, when we are inside the cluster, right, we are directly able to do it, right? We are directly able to send the request to the pod, but we don't want, right? Client does not doesn't want to reach out to each pod. What we are trying to do is client is sending a request to cluster IP service, and then in the backend it is sending the request to any of the pod. Because what is the problem here is, if in case any of the pod get deleted, right, so this IP address will get changed. So I will not know the IP address of this pod, but instead, even if these three pods will get deleted, I'm sending a request to cluster IP. These three pods, because it is a deployment, ultimately new three pods will come and request will go any of this pod, and my service will keep on serve, I mean, my request will keep on serving, right? Client will never get downtime. This is static. The IP of this cluster IP service is static, right? So we have understood in this example, right? Now, in while we were discussing about the architecture, we also discussed, like, let's say, if we are creating a DB pod, right? So what will happen if a pod we are creating called DB pod, then we will be able to access, yes, we will be able to access by using the IP address. But let's say if you want, by using the IP address directly, the way we have just now saw, right? We curl and I gave the pod details, pod IP, we will be able to do it. But let's say if there is any deployment here, and that is ensuring that, okay, minimum one number of pod is always maintained there. In that case, what you need to do is you just need to create a, you need to expose it to service, right? Uh, yeah, see, you need to expose it to the service. Okay, from outside, if you will try to access, if you'll try to access, the request will get failed immediately. That will happen, right? If you are trying to request from this pod to here, then this will get failed here itself. The request will get failed. Okay, you will not be able to reach to this pod directly from outside. Okay, first you need to log into this one pod, and then if it is a deployment, then you create a service for that deployment, because you can directly reach out to the pod using a curl and put the IP address. But if it is a deployment, the pod will get deleted in, if in case the new pod will come and the IP address will get changed. So in that case, you need a service to be deployed on top of pod, right? So you need to expose. What command you have to write? You just need to write here a command called, I mean, let me write here itself. So you just write kubectl expose, and then you need to write pod. Okay, if it is small, let me zoom here. Okay, what I'll write, kubectl expose pod, and then I will give my pod name. Let's say if it is a DB pod, right? I will give DB pod, and then I'll open any port here. Okay, so port equals to, what is the port? That, let's say 3306, and I will mention the target pod. So I'll mention target hyphen port equals to, let's say 3306 again. Okay, 6, and then what I will mention here is name. Okay, what is the name of service I want? So hyphen name, name equals to let's say db hyphen service. Okay, this is the service equals to type equals to, I mean hyphen hyphen type equals to cluster IP. Okay, so if this command you give, right, what will happen is you will be able to create a service. Okay, so it will create, it will create a service for you. You will be able to create this service. Okay, so this service, once you are able to recreate, then even if this pod will get deleted, a new pod will come, your request will never die. Okay, so you just have to send a request to your client will send a request to your db service, this cluster ip service. Okay, and then it will be able to request it to the pod. Okay, this is very simple actually. Send it to back, export. Here there is no option, I think. uh, so I will just change the color back to white. Okay, so I hope you have understood. So this is my cluster IP in this case. This is overall, it is a cluster, and and you are able to serve the request. Okay, so we have seen everything in live using this commands as well. Okay, now let's suppose you don't wanted to execute this particular command, right? So what you need to do is in your in your YAML file only, what you need to do is you just needs to write a script like this. Okay, you just uncomment this with a separator. You create another service and you can name it as a DB service. Okay, it is a cluster IP type. You can make any selector name. I mean, you can give any selector name, and then you can just give port and target port. So what it will do is it will create a based on the pod name, DB pod, it will create a select cluster IP for it, and then you just send a request to cluster IP. Okay, so I hope you have understood this concept of cluster IP service in Kubernetes. Okay, let's catch up in the next video where we are going to learn about the NodePort. Thank you guys. So in the last video, we have seen about the cluster IP service where we have logged into one of the client that is nothing but a pod. And then through that pod, we were able to request to all the pods inside the node, right? So cluster IP was the first point of contact with a static IP, okay, which even if the pods will get down and all, new pod will be created and it will route it easily. Okay, so these all things we have learned. So now what we are going to learn today is, so I will take you through another example. Here there is another file I have. If you can see my screen, so this is a cluster IP underscore 2. This is the another YAML script I have. I will do some changes here. Okay, I will make it as 81 here. Okay, just to confuse and make some errors, right? So that we will learn. Okay, so the main agenda of today's learning will be how this ports transfer the request whenever they gets, right. Okay, let's say backend service will get the request, so how this we will know, okay, this is we have to route it to this port only. Okay, so all this information we are going to see it now. Okay, so let's say what I'm doing is nothing different here. Again, 6 pods I'm deploying and I'm exposing the port 81. Same way I am creating a service, naming it as a backend service, and the port for this backend service is port 82. Okay, so it is going to listen on this port, and the target port is 81, right? So this is the target port 81. So now let's say what will happen. We will go in the demo only. Let me meanwhile let me apply this file as well. Okay, kubectl apply -f dot slash cluster IP service 2. I will deploy this file. Okay, it will get deployed. Meanwhile, let's understand what is the problem here and what we are going to learn here. Okay, so today I will log in to login port. Okay, so this will be my entry port here, and through which I will try to send a request to backend service, that is this service, okay, which is listening at port number 82, and then through which I will send a request to target port 80, 81. Okay, so this which is mentioned here. Now, if somebody will do some changes here, like how we will identify which port actually they are listening, we are going to learn those aspects. Okay. So this is my login port, right? So let's change into the diagram also so that it will be easy to correlate. So today I am going to learn on login on the login port. Okay, so from login port, I'm going to send a request to ClusterIP service, right? Okay, so that's the thing. I think it should be deployed by now. Yeah, it got deployed. Okay, so first query, what we are going to execute and we need to see here is we will see like we will see okay, let's first log in, then we will discuss later. Kubectl, then exec. Okay, go first kubectl get all. Okay, so here you can see, okay, it is in still in creating state. Okay, so it is we have a login pod and client pod we have created yesterday itself, and we have got backend service that is a cluster IP service with this IP range. Okay, so what I will do is first of all I will try to do same process. That means I will log into this login ID login port, and then from the login port I will try to go inside the backend service, or I mean I will hit the cluster IP address for this one, and then we will see whether we are getting the result or not. Okay, so what command we have seen yesterday, it was kubectl exec -it, then what is my login pod, right? That is there, and then hyphen hyphen backslash sh bin slash sh plus sh. Okay, so you will log into the pod. Let's wait for a couple of minutes. So what is the error here? It took time basically. So it is saying like container not found. So maybe because of this internet issue, this pod container is still creating, right? So it is not available. So we need to wait for a few more time to get these pods, all these pods available for us to run. Okay. So let's hold on for a couple of more seconds. Okay. So it is creating. Login port is still creating. Couple of them came into running state, which is good. Okay, let me check the status again. Okay, everything is running now. Okay, now what we will do is we will log into the pod. Okay, now I am inside the pod. Okay, now what I will do is curl and I will hit enter to this particular IP address, because this is my IP address, right? So what I'm trying to do is from my login port, okay, I'm sending a request to cluster IP service. Okay, but let's wait whether it will succeed or not. We need to see that. It should fail, right? Why it will fail? Because it is pointing to port number 80, but when we expose this port in our YAML file, we exposed it to port number 82. Okay, so what we need to do is let's give it here port number 82 and hit enter. Okay, so now it is telling, right, failed to connect to this port 82 after 0 seconds, so could not connect to the server, right? So in both way you have tried, but it failed, right? Now what is happening, that we have to see now. Okay, so what we will do is we will do the exit, and if you understand in this diagram, okay, or let's say here only, you are mentioning it to the receiving port as 81. Okay, here it is 81, but is it really a 81? when we when we mention anything on container port equals to 81, is it going to bind it in actual? That's not the correct statement, right? To check that part, let's go and execute few commands so that you will understand. Okay, first command what we will execute is first get the okay we have this pod names, right? So we can take these pod names from here only. I'll copy any of the pod name and we will see that these pods, right, these pods which are created here, they are listening on which port. Okay, so let's say you are here and when you are sending a request to pods, but pods are not listening to port number 81, right? Then it will definitely fail, right? Suppose it is listening on port number 80 and your request as per your YAML file is going on 81. So for 80, this cluster IP address will never be able to reach out. Okay, and the request will never go from here to here. Okay, so let's first understand what is the listening port for our pod. Okay, so we will do kubectl exec and then I will mention my pod name. Okay, and this is the command. Let's start and hyphen ul. Okay, so now you see this is listening on port number 80, right? So that's the difference. That is the problem statement here. Okay, that is something we need to understand. So each pod here, right? If you will take any pod name, they all are listening to port number 80 and port number 80, right? They are all listening to port number 80, but you are when you are trying to send the request, right, in YAML file, you are sending the request to the target port that is 81. Okay, same thing we can see into our command prompt also. Let me show you here. Okay, so kubectl get service. Okay, and my service name is, what is my service name? Backend service. Okay, I'll do control C control V. Okay, and I will give the output as a YAML. So you see, it is the target port for the cluster IP service is sending the request to port number 81 and it is listening to 82. Okay, so what is happening is, but here we saw, right, pods are trying to listen on port number 80, but our cluster IP address is sending it to 81. So there is a mismatch, right? They are ready to listen on 80, but we are sending out port number 81. So it is going somewhere else. If the request is getting failed or timed out. Okay. So to understand more on this one, let's see how we can also check few more details like kubectl get. You can run a command describe. Okay, and then service service, and you can mention the service name. Okay, when you will hit enter, you see your port of that service is 82. That is fine. Your target port is 81. Your all the endpoints, all the IP endpoints are going to port number 81, right? They are all going to 81. But what is our port number? You see, if I execute a command, kubectl get all pods -o wide. Okay, so you see 10.2.66 10.2.66, and the request on this port IP address is correct, but the request is going on port number 81, right? But actual port for this is port, all the pods are trying to listen on which port, port number 80, right? So there is a mismatch and that is why it is happening. Okay, so what we should do is, that is the error and that is why requests were not going. Okay, so I will quickly delete it and kubectl delete -f ClusterIP service _2. Okay, what I will do is I will delete all the resources and I'll recreate. Meanwhile, let's go and change into the YAML file. Okay, so this does not make any difference. This is just an, I would say, this is just an metadata which is telling all our developers that okay, behind the scene, okay, behind the hood, the image was exposed at port number 81. Okay, do you want, okay, let me show that part also before I create a new resource. Okay, so let it get deleted. Okay, so this is not making any sense. Even if you'll keep any other, the binding is not happening on this is not going to change the bindings basically. Okay, if you wanted to change the bindings, you have to go and change into the configuration file. Okay, so what we need to change, so currently what we have learned, so as per our diagram, right, these all are trying to listen on port number 80. So the actual mistake was here. Okay, so we need to change it to port number 80. Okay, so first debugging we have seen, right, how to check pod's port using the commands which I showed, right, cube exec your service, I mean, or your pod name -hyphen netstat -tuln. Okay, so that command you can give and then it will work. Okay, you will be able to see on which port your pods are listening. Okay, so next thing is as I told, let me show you let me show you the Docker file as well, and I will show you where they are getting exposed. Okay, so okay, so it got deleted. Now let's do one thing. Docker inspect, and my file name is, or my image name is this one, right? I'll control C, control V, and I'll hit enter. So if you do the inspect, right, you see somewhere config and you see expose. So it is telling like expose ports are 80 and 81. Now you might be confused like, okay, port 80 and 81 both are exposed, then why still the request was failing? Yes, as I told, right, even if you can write any port while exposing, but binding is done in the configuration file on port number 80. Okay, it does not needs to be whatever number you mention on the expose while doing the expose. It is just for your convenient and it is just a metadata which is telling that okay, behind the scene it is exposed to port number 80. So what we should ideally do is uh, in our file as well, right, in our Docker file we should write expose port is 80 only. Okay, now this is what we have got to know, that okay, there are two ports are open. But now let's see one more thing. Okay, so what I will do is docker run -d detach mode and then name. I'll create a test container. Okay, and then I will give my image name. So it will run the command. Let's wait for a couple of seconds. So okay, so docker run started on my test container. Okay, now what I will do is let's go inside this docker exec test container. Okay, netstat -uln. Okay, now if you see the port, the container itself is trying to listen on the port number 80, right? So that is something we need to understand, and this is something we need to learn, that whenever there is a port mapping we are doing, we first let's check what is the container port it is listening, or what port the pod is listening, and then we should roll out the changes. Okay, you can use this commands. So this tells that okay, your service is going to send the request on which port, Okay, and this command will tell you your pod is listening to which port. Okay, yeah, so these things are important. Now let me docker stop test container docker rm test container. Okay, so these things you have learned, right? At a docker file image level, I have also shown you that if even if you are mentioning the expose here as 81, behind the scene it is still taking 80. Okay, so that is what I would try to show. Now let's try to save this file and try to run this file. Okay, so what we will do, docker apply -f /c cluster IP 2 and I'll hit enter. So let all the pods get created. Okay, what command I ran? Docker apply. Okay, it should deploy your pods. So it has started deploying the pods, and in couple of seconds we can see all the pods also. kubectl get all. So you see, yeah, it started creating. So it will take couple of seconds, and this is my cluster IP address. So now what I need to do is, if we discuss in the diagram, the login port, first I will log into this login port, then I will go to the cluster IP service, and then it will take me to the correct port. Okay, so let's wait for the containers to run or pods to run to be in running status. It is still creating. Okay, almost all is ready except last one. Okay, everything is running now. So what we'll run is docker exec-it. My pod name is login pod, and then what I'll give is plus sh. Okay. Docker. Oh, it's not Docker. It's kubectl command. Kubectl. Okay, so now you see I am inside it. Now what I'll do is I'll do the curl and I will share my cluster IP address. Okay, what will happen? So if you see URL, will it take the request? No, right? Because I have not mentioned port 82. But if you see our file, here we have mentioned that cluster IP address will only listen at port number 82. So it is gonna fail in 20 seconds. Okay, let's wait for a few more seconds. Yeah, it got failed, right? Now what we should do is we need to mention the port number 82, and I'll hit enter. So now you see it has taken me to the right port, right? Earlier, what was the problem? We were trying to mention on target port was different, 81. So this does not make a sense, right? You see, right? Even if it is 81, 82, this does not making a sense because this image is bind at port number 80. This is just for a developer convenience that okay, behind the scene it is on port number 80. Okay, so target port is port number 80. How to check and all, I have already shared the command, and then once you run it, you will be able to execute and able to see it. Okay, so thank you guys. I hope you have liked the video, and this is very critical to understand. Just go through it this video 2 or 3 times, but it's not very hard. Main thing you need to understand is your target port and the port to which your image is bind should be same. Okay, this can be a different. This is just a metadata, and when you send the request, you have to send a request to the same cluster IP to which you are opening the port. Okay, thank you guys. Have a great day. We'll catch you in the next video. Hello everyone. So in the last video, we have learned about the cluster IP service. And in this video, we are going to learn about the NodePort service. Okay. So cluster IP service, we have learned, right? That if we wanted to send a request or we wanted to use the port inside the cluster, and if we are deploying the cluster IP service, we will be only able to access within the cluster. So first we have to log in into some pod, and then from pod, you have to send a request to cluster IP service, that is cluster IP service, and from cluster IP service you will be able to communicate to the pods. This is what we have learned in the last video, right? We have to log in into the some login pod, and from there you will be able to. But if you are sending a request to the cluster IP service or these pods, the request will get failed. Okay, so there was no possible communication you can do directly from the pod. Mainly for the devs and QA team, it was not possible using cluster IP service. So when we are using the NodePort service, right, the developers outside the clusters or the QA team will be able to access these pods directly, right? What I'm trying to say is when we deploy the NodePort, actually we have already discussed these points in the previous video where we have discussed the architecture. Please go through and understand that concept. Okay. So when we deploy the NodePort behind the hood, it is also deploying the cluster IP service. Okay. So let's say if we are sending a request to the NodePort service, this is my port number, and why this port number is there and all, you have to go through and understand the complete theory in the previous video only. Okay, so in this video, I will only target to demo it. Okay, so what I will do is first I will clear my system CLS and then I will apply. So I have already written this. I will apply this file. Okay, so NodePort demo this file. So if you see currently it will take couple of seconds to deploy and go into the running state. Okay, so let's check it. kubectl get all. So container is currently in creating state, and this is my port number which I have already declared in my file, right? So if you see, this is my file. Meanwhile it is getting into ready state. We can discuss this file. So this is nothing but a deployment. We are discussing about this deployment in almost in every video. The complete video you can go and check into my previous video where we have discussed about application controller, replica set, and deployments. Okay, so this syntax and all I have explained it. The important thing here is we have to learn about the services. Okay, the services we are declaring of type NodePort. In the previous video, we have declared it as a cluster IP service, right? Cluster IP of the kind service, but here it is NodePort of kind service. Okay, you can give the selector, and that's nothing but kind of tags. Okay, again, this has been discussed a lot in the previous video. So what is this port? So I'm mentioning it as a port number. So what is the port number of my NodePort? So here it is 81 and target port is 80. So all my India website, right? That is my image. So this is going to listen at a port number 80. Okay, so containers are listening on port number 80. That is why we have mentioned as target port, and node port is So this is the node port which I am giving. If you are not giving or if you are commenting it, so Kubernetes will assign any random number between this high range port. Okay, so by this time I think that must be deployed. Let's go and see this. kubectl get all. Okay, so everything is in running state. Okay, so what I will do is, if you see in this diagram, so I have deployed one Kubernetes service that is called NodePort, which is having this IP address, and this is listening at port number this. Okay, and ClusterIP service also it has created, right, behind the scene. If behind the hood it has created a ClusterIP service also. So what I have to do is, first I will use, and I'll show you. Basically I will copy this port number. Okay, and after copying, let me show you in the diagram also what I'm trying to do basically. So I'm going to send the request to this port number, and this will automatically take care of routing it to my website. Okay, so this is my port number. I mean this, let's open this website. I think the port number is same. I'll just paste it and I'll press enter. Okay, so if you see, it has started giving me the output, right? So why I'm using India traffic? Because in the next, or maybe upcoming, in the next video itself, I will try to show about the load balancer service, where I will demo about the Australia traffic and India traffic, and you will see how beautifully this load balancer will route the traffic to different websites or different apps. Okay, so I think this video makes it, I mean this concept is clear for you. So in the previous video we were only doing everything from the command prompt, where we are first logging into the port type is any pods, and then from pods we were trying to access the website. Okay, so I'm deleting it. What I will do is, in this video itself I will demo about the load balancer also. So this one, if you see, I have a load balancer file. Okay, so if you see, I have two demo deployments. Let me even do it so that meanwhile I'll explain, this will be ready. Okay, so kubectl apply -f, then my local load balancer 1, and I'll hit enter. Okay, so it is creating, and meanwhile it is getting into continuous getting ready state. Let's discuss this. Okay, so what I'm doing is, I am deploying a India website. Okay, which is on, I'm deploying 4 replicas, again, which is listing on port number 80. This does not matters, right? We have already discussed this. Okay, so target port is 80, and let's change the port number for my load balancer as 81. Okay, and then in the next one, what we will do is, container port is 80 only. So this is all deployment, right? So this is deployment, and this is load balancer service. So here, what is this service? Kind of service, and type is load balancer. Okay, so what is the port you are opening this load balancer, that you have to mention. So I'm mentioning port number 80, and where I have to send the request, I'm telling that, okay, port number 80 is your target, so there you have to send it. So that is for India, and this is for Australia website. So this we have, this is nothing but same. This is a deployment of 4 pods. Okay, what is important here is, this is the again a new load balancer which is listening on port number 80. Okay, and sending the request at port number 80. Okay, so we can deploy this one, or I think it's better to discuss about this. Okay, because there you might get confused, like, okay, why we are deploying 2 load balancer. That also you can do, but what ideally we should do is, okay, let's say you have I think I should deploy this. Okay, so I will delete this load balancer. Okay, let it get deleted, and I will apply kubectl apply -f load balancer 2. Okay, so what we are going to do here is, you see there is one India deployment where I'm doing 4 pods deployment using my image, which is listening at port number 80. Okay, and this is Australia website, which is again listening on port number 80. And then very simple, I will just declare, I will deploy one load balancer, right? In the previous video, I could have shown it, but what we have to do is we have to send 2 requests at 2 different ports. Okay, port number 80 or port number 81. So then, so let's say here 82 for this load balancer, which was not needed, right? For this demo, it is better to show only one load balancer, and which should route it to the different websites. Okay, so if you have understood, right? Here I'm doing the Australia website deployment, and here I'm doing India website deployment. Okay, after this, there is one load balancer only. Okay, and let's understand this file. So it's a kind of service. I have given the name of that load balancer. Okay, and this is all spec where of type is, what is the type of service? This is of load balancer. Okay, I have given one selector here, that is my website, to do any filter if required in future. And I am opening the port of my load balancer as port number 81, and I'm sending all the requests to target port 80. Okay, so if you see here, I'm not giving any port number of NodePort IP. All right, so what it will do is automatically Kubernetes will declare or define that port number. Okay, NodePort and ClusterIP service I am not defining in this file, but load balancer, whenever it will get deployed, it will automatically deploy those things. Okay, so let's get to this command prompt and see here. So kubectl get all. By now everything should be ready. Okay, so you see there are 4 pods running into India websites and 4 pods running into Australia. Okay, so I have deployed a load balancer, but behind the scene, if you see, it has also declared a ClusterIP service. Okay, now what we need to see is, what we have to do is we will send the request to load balancer of port 81, and you see this is also matching behind the scene to any NodePort service also 30,493, right? So this will send a request to this one, and again it will send a request to ClusterIP service. So here in this example, what we will do is we will just use localhost and port number 81, right? So let's see here, localhost, and I will change it to port number 81, and let's see how the traffic will go. So you see Australia traffic came, right? And now let's continue to refresh. So Australia again. Let's keep coming. Let's see when it will route till going in. Yeah, you see, right? India. So you can see it has also routed to India traffic now. So this is the benefit of load balancer. Now it is all coming to the India traffic. Everything is coming on the India traffic. So that is website it is loading. Okay, if I'll keep refreshing. So somewhere you will see Australia also. Okay, it is still India, but we have seen, right, now it is coming as Australia. Okay, so this is the benefit of having a load balancer service. And you have seen, like, okay, we are routing the service from India to Australia or Australia to India using a single deployment file, right? This is the single deployment file we have. What we have done here is we have declared one load balancer, and 2 services were there, 2 deployments were there, which were hosting 2 different images. So based on the load balancer, it was routing it to different websites. Okay, using single load balancer. Okay, so I hope you have liked this video, and this video will help you to understand more on load balancer and NodePort. Okay, we will catch you in the next video. Don't forget to subscribe so that it will give a motivation to me also to upload new and more videos. Thank you guys. Thank you. Have a great day.